The chemical equation. We use chemical equations to represent chemical reactions. So in math we have equations that represent things that are being done with numbers. So a chemical equation is somewhat like a math equation. On the left side of the arrow, we use an arrow instead of an equal sign. On the left side of the arrow are the reactants. So over here, these are the reactants. And on the right side are the products. So it starts on the left and goes to the right. The arrow is pointing in that direction. These are what are reacting. The reactants react to produce the product. We often indicate the physical states of the reactants and products, but not always. When we do, these are the abbreviations we use. G for gas, L for liquid, S for solid, and AQ stands for aqueous, which means dissolved in water. And we'll learn a little bit more about that later. So let's look at this chemical equation. This is the description of the combustion of methane. So here we have CH4 and oxygen. Methane, by the way, is an organic compound, and it's named with a different set of rules, and we haven't learned how to do that in this class, and we're not going to. So if you're wondering why isn't that carbon tetrahydride, that would be why. So CH4 reacts with oxygen, and the products that are formed are carbon dioxide and water. Now if we look at this, over on this side, one molecule of oxygen has 2 oxygen atoms in it. And the reason this is O2 is because oxygen is one of the 7 diatomic elements. Remember, horses need oats for clear brown eyes? The O in oats is oxygen. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All of those elements, when they're alone, form a diatomic molecule. So that's why it's O2. So there's 2 red balls over here. And if we look over here, we've got one molecule of carbon dioxide that has 2 oxygen atoms. And in this one molecule of water, we have 1 oxygen atom. So over here on the right, we have 3 oxygens, or 3 red balls, and on the left we have 2. Where did the red ball, that extra red ball, come from? Can red balls appear out of nowhere? No, they can't. There's something funny going on with the white balls too, the hydrogen atoms. Over here we've got 4 white balls representing the 4 hydrogen atoms in CH4. If we look on the other side of the arrow, in the products, we only have 2. What happened to the other 2 hydrogen atoms? Did they change into 1 red oxygen atom? No. We have to have the same number of hydrogen, oxygen, and carbon atoms on each side of the reaction arrow. Law of conservation of mass. Matter, really. Matter is conserved. It's neither created nor destroyed. We can't create or destroy atoms in a chemical reaction. So we have to fix that. We have to balance the equation. So what we're going to do is we're not going to change the formulas, but we can change the number of molecules of each. So if we say, well, there must have been 2 of these molecules, and we must have made 2 of these, if we do it like that, then we see that we've got the right number of carbons, hydrogens, and oxygens on each side. Now we've got 4 hydrogens over here and 4 hydrogens over there. We've got 4 oxygens here, 2 here, and 2 more is 4, 1 carbon and 1 carbon. You could do this with Lego blocks too. You could make this little thing and these 2 things, and then in the chemical reaction what happens is you take these things that you made apart and you put them together in a different way. And that's a perfectly okay way of thinking about what atoms do in a reaction. Here they're stuck together in one way, you pull them apart, you put them together in another way. But you can't just pull new blocks in from nowhere, and you have to use up all the blocks. You can't have leftover blocks. What you start with is what you end up with. Does that make sense? We have to grasp the picture idea of this before we can really go on. So then when we describe this reaction accurately, we say that one molecule of methane reacts with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of water.